Okay, so we're still in alcohols. This is your last section. It's pretty short. It just has to do with thiols. So when we talk about thiols, what we're talking about is a functional group that includes some sort of sulfur hydryl group, all right? It will be bonded to an sp3 hybridized carbon. So we know sp3, it's got 1, 2, 3, 4 groups, making this an sp3 hybridized carbon. And this right here is your functional group. So our carbon SH bond angle is approximately 100.3, and that's in methane thiol. It indicates that there is more P character than not. All right. I'm less concerned about you knowing angles, more concerned about you understanding the concept. So when we talk about naming, we have, of course, our IUPAC names. Same rules apply so far. Longest carbon chain, but it must contain the thiol group, that SH group. And it's got to be in the parent chain. The E gets changed to thiol. Now, here's a couple of things that are different. When we're naming, remember we talked about with alcohols, the hydroxyl takes, should be on the shortest, or not the shortest, the smallest carbon number. Well, hydroxyl groups take priority over the thiol group when numbering. So if we had this, that's really bad, y'all. If we had something like that, we are not going to number 1, 2, 3, 4. Actually, I messed that up. Let me just pick a different. I didn't count properly. Sorry, y'all. Okay, we are not I should have planned this better. Again, my apologies. Not gonna number 1, 2, 3, 4, 5. We are not going to do that because hydroxyl gets the lowest number priority. So we're actually going to number it 1, 2, 3, 4, 5. That gives the hydroxyl group the lowest carbon number. Okay, so hydroxyl groups do get priority to the lowest numbered carbon. If we have both functional groups, the SH group is, we know there's an SH group present by using sulfonyl or by the common name mercapto. So let's look at the common names as opposed to IUPAC names. So our top line is going to be IUPAC. Our bottom line is going to be common. So for the first example, 1-butene thiol is your IUPAC name, but the common name is butyl mercaptan. Second one, we got the thiol on the first carbon, methanol group or methyl group on the second carbon. So 2-methyl, 1-propane thiol, or isobutyl mercaptan. This is where it becomes important for numbering on the third one. Hydroxyl will get priority over the thiol group in order of lowest carbon number. So 2-sulfanyl ethanol or beta mercaptoethanol. Why? Because this is a beta carbon. It's up. So we're not really going to look at hydrogen bonding when we have this SH bond. You do see SH hydrogen bonding in things like proteins, amino acids, DNA, etc. That's what causes different structures of our proteins. You've probably talked about that in biology class. But for us, it's less important. We have lower boiling points and less solubility in water than that of alcohols. So if we're comparing boiling points, if we look at, for example, ethane thiol here compared to dimethyl sulfide here, note the difference is that SH group versus just a sulfur group, all right, then we're really not talking about a huge difference in boiling points. Because of the low molecular weight, that they're pretty small, thiols have an awful smell. They're gross. In fact, when you're doing labs that involve thiols, everybody in the building knows it. It smells worse than rotten eggs. Skunks, good example of the smell from thiols. And for skunks, it has to do with the 2-butene 1-thiol and the 3-methyl 1-butane thiol. So we often add the thiol smell to natural gas. Natural gas you can't smell at all. It's completely odorless. So that we realized many years ago, a long time ago, that if there was a gas leak, nobody would know until it was too late and there were huge explosions. So we had to add that sulfur smell. If you've ever had a gas oven or stove and when you first turn it on, when it's first starting to go, you can kind of smell that sulfury, yucky, rotten egg smell. We intentionally put that into natural gas so we know as a safety precaution if in fact there is a natural gas leak. So when we talk about preparing these thiols or forming these thiols, what we're talking about is a very strong nucleophilic properties of the sulfide ion, the hydrosulfide ion. So what do we mean by that? Well, if we were to look at 1-iododecane and we were to add it to sodium hydrosulfide, this is going to go by way of an SN2 reaction in the presence of ethanol. Now, what you have here with this 1-iododecane, you'll notice that's not an alcohol, but when we treat it with sodium hydrosulfide, what we're going to get is a thiol, a 1-decane thiol, and that's on the end there is where that thiol is going to add. So what we're going to see is that iodine goes away, and this is what attaches. All right. Commercial applications of thiol formation, we get sodium salt of the thioglycolic acid. We get that by sodium hydrosulfide. What's happening? There we go. Sodium hydrosulfide with sodium iodoacetate. So what do you see happening? What we see is that this comes off where this gets added, and we have a combination here. This is an SN2 reaction, and our other product is the sodium iodide. Thiols are stronger than acids and alcohols. If you look at their pKa, by the way, I don't know why this isn't showing up. This is supposed to be an arrow, and so is that. If you look at their pKas, and we compare, for example, the alcohol to the thiol, what we're going to see is a much lower pKa. That lower pKa indicates to you that it's a stronger acid. Remember, the lower numerical value of the pKa, the stronger the acid. The closer to 1, the Ka, the stronger the acid. So if we were to dissolve a thiol in a very strong base, such as sodium hydroxide, we're going to completely convert the thiol to an acyl sulfide salt. So what does that mean? Well, if we have this thiol here, this is going to come off, this is going to get added. What we're going to get from that hydrogen and this hydroxide is water, you can consider a thiol with a strong base a neutralization reaction. By the way, recap, neutralization, acid plus base yields soluble salt plus water. So the sulfur atom can be oxidized to several different oxidation states. What do we mean by that? Well, if I have a thiol here, here's my thiol attached to some carbon group. We don't really care what the carbon group is. Couple of things can happen. We can oxidize it to get a disulfide. You see this a lot in biochemistry and biology. Or we can oxidize it to get this sulfinic acid. You should recognize that it looks very similar to the carboxylic. Instead of a carboxylic, we're getting the sulfinic. So if you remember, carboxylic is this. The only difference between the carboxylic is instead of a carbon, it's a sulfur. That's the only real difference there. We could further oxidize this into a sulfonic acid. Here's our sulfonic acid. How do we know it's a sulfonic acid? Because that hydrogen would be donated. So as far as interconversion between thiols and disulfides, I'm less concerned that you understand the reaction mechanism, and I'm more concerned that you understand kind of what's happening. So if we start off with a thiol and, for example, iodine, what we're going to get in the end is hydroiodic acid and this disulfide there. When we oxidize to wow, words are hard today, y'all, to disulfides, we can do this by molecular oxygen. What is molecular oxygen? Well, we know oxygen gas is O2. Molecular oxygen is just a single oxygen. All right, so what's half of O2? One oxygen. So when we do this, we can see that the hydrogen comes off, and we're going to get water, and we're going to get a thiol to a disulfide. When we're doing this, the most important piece is that it's protected from contact with air. Why do you think that might be necessary? Why do you think that's a part of this? Well, because it's highly susceptible to oxidation. There's oxygen in the air. If there was oxygen in the air, then we can get some other stuff going on and we won't maintain our disulfide. That's it for thiols. Told you this would be a super quick lesson. I'm going to be putting up Chapter 11 very soon. Stay tuned.